Okay, so now I'd like to talk about how does bone get bigger, and specifically we're talking about during development, during puberty, during growth as a child, those sorts of things. So we're talking about big changes. We're not talking about the natural remodeling that occurs. And so specifically during development, we can have two types of bone development. One is called endochondral ossification, and then the other one is going to be called intramembranous ossification. I think it helps if you're thinking about what are the mechanisms or what is the way that this bone growth occurs, is to think about the words themselves. So we have endochondral ossification and intramembranous ossification. So let's take those words. Okay, so first of all, we have endo and then chondral. Well, we know chondra has something to do with cartilage, and endo is going to mean inside. And then, so let me write these here. So endo is inside, chondral has something to do with cartilage, and ossification, well, we know that OSS is going to refer to bone, and so it literally means bone making. So if we're looking at this, it literally means that we're making bone inside of cartilage. Okay, so that is endochondral ossification. Intramembranous, and on the other hand, again, ossification still means bone making. So intramembranous, inside membranes, bone making. Okay, so again, literally making bone inside membranes. Okay, so this is going to be the difference. Let's start with endochondral ossification and talk about what happens there. This is going to be specifically referring to how long bones form. Okay, so as the name implies, endochondral, inside the cartilage. Turns out whenever you're first developing in the uterus, you don't start out with bones. You actually start out with cartilage, where your bones will one day be. Okay, and so what happens first off is that this cartilage, the chondrocytes in the cartilage, they begin to get larger. Okay, so those lacuna get quite large, and then those chondrocytes die off. The next thing that's going to happen is that a blood vessel is going to come up next to the side of this cartilage, and it brings with it cells that can turn into osteoblasts, okay, and all the different complement of bone cells. And so what happens, the first thing it does is it lays down a little bit of bone on the outside of the diaphysis. It's called the bone collar. But eventually what you notice is that this blood vessel invades into the middle of the bone. So that's what it's done here. It started out just on the edges, but now it invades into the center of the diaphysis. When this happens, it brings along bone-making cells. And these cells find empty lacuna. And they say, hey, free home. Let's just go set up residence in the lacuna. And once there, they start tearing up the cartilage and putting down bone in its place. Now, this first place it happens is inside the diaphysis. So because it's first, we call it primary, meaning first. And then ossification, again, means bone making. So literally the primary ossification center is the first bone making location, which is right here. Let's continue. If you notice now, this medullary cavity has been enlarged. So at the same time we're laying, and the cartilage in the diaphysis area has been completely replaced by bone. So at the same time we're laying down bone tissue, replacing the cartilage, we're also tearing up the inside to hollow it out to give us this medullary cavity. So now this whole center portion is bone. What happens now is that we get two secondary ossification centers. We have new blood vessels that invade the epiphysis region and set up a bone-making center, one in the epiphysis here, another in the epiphysis here. And this starts making bone, tearing down the cartilage from the inside out and replacing it with bone. Now we're going to do a close-up of just this epiphysis to see what happens. Okay, the first thing that we're going to see is, again, we've got a region here, and on the outside we've got cartilage. Okay, and so now here's the diaphysis, here's the epiphysis. We have bone growth going from the inside out on both places, and in between we still have a bit of cartilage. This is called the epiphyseal plate. As long as you still have this bit of cartilage that can be replaced by bone, your bones can continue to grow longer. But eventually, this epiphyseal plate will be completely replaced by bone, and at that point the bone from here has fused with the bone down here, and we have what's called the epiphyseal line. And at this point you're done, your bones are done growing. You cannot grow in length on these bones anymore. Notice that you still maintain a little bit of this cartilage right here. It is the articular cartilage, so this is the part that will be in contact with another bone up in this region. So this is endochondral ossification. Okay. Now, just a little bit of information from the notes here, talking about the different types of bone growth. Endochondral ossification begins as an embryo. It'll continue through 25 years of age. Okay, so it actually can continue a long time. Some of your bones don't have those epiphyseal plates fully replaced with bone tissue until you're 25 years old. Okay, the types of bones that go through this type of growth, so upper and lower limbs. The pelvis can go through this, the vertebra, and the ends of the clavicle, the ends of your collarbone. Okay. Now let's talk about what intramembranous ossification looks like next. Okay, so first of all, with intramembranous ossification, you're going to start with a dense connective tissue. Okay, and this is going to particularly happen in the skull. So you start with that, and you have these mesenchymal cells that can differentiate into osteoblasts and then osteocytes. Okay, so osteoblasts initially start laying down bone matrix, and so what you end up with is you end up with these very small ossification centers inside of this connective tissue. As these ossification centers begin to grow, then they start to fuse together. So notice here, started out with individual ossification centers, and now they fuse together. This one has fused with this above. These two have fused together. Okay, and so essentially you're replacing this membrane tissue with bone. Now these blood vessels that are throughout the membranous connective tissue, those blood vessels get trapped inside the bone matrix, and that's what helps continue to supply this type of bone with the nutrients that it needs. And so eventually you end up with complete bone tissue where all of these individual ossification centers have eventually fused together. Now, this type of bone growth, again, it begins as an embryo and through about 2 years of age. So it actually doesn't complete until 2 years of age. One of the big places we know about it is the skull. The skull bones form by that, and so they haven't completely fused together until 2 years of age. And so we'll talk about this more in the axial skeleton lectures, but the baby soft spot, it's because that ossification hasn't completed. So some of the bones, or some of the structures here are bone, but then there's a part that is still that connective tissue membrane that hasn't yet been converted into bone. So the skull is going to have that, the lower jaw, most of the clavicle, and then the patella. Okay. And so that's what we're going to find with intramembranous ossification. Now, the other type of growth we need to talk about is appositional growth. We talked about this a little bit whenever we talked about cartilage in the tissue lecture, but let's talk about appositional growth. This is showing here an infant, and notice as they grow into a child, they're continuing to lay bone matrix around this periphery. Okay, that's appositional growth. That's how you get some of those circumferential lamella, okay, is adding to this outside. Okay. Now notice that as we continue to add to the outside, we're also continuing to hollow out the inside. So we end up with wider bones, but that inner portion is also more hollowed out by the time you get to an adult. Okay, and so this is something that can continue to happen for many years. Okay, and so those are the different types of bone growth. This shows you what it looks like when bone growth continues in inappropriate ways. And here are some activities to help you both order the steps of ossification and understand what these different terms mean.